Advanced installation issues. In this nugget, we're going to discuss a couple of advanced concepts: RAID and logical volume management. RAID has to do with organizing multiple disks or partitions on disks for a higher performance or higher reliability or both. Logical volume management gives a system administrator a set of tools to help them manage disk partitions, basically. So put on your thinking caps and let's get to work. Well, what is RAID anyway? Well, RAID stands for Redundant Array of Independent Disks. Sometimes you'll see the acronym Redundant Array of Inexpensive Disks. They both describe what RAID is. Basically, back in the early 90s when RAID was developed, there was an increasing need for large hard disk storage capacity. Okay, we were taking on projects like the Human Genome Project or SETI, which here the processor says, okay, I'm going to write file F to this disk, and I'm also going to write file F out to this disk. So the logic, the RAID logic, is actually in the processor. So the processor is more burdened here, right? The processor generated 2 writes to 2 different disks. The processor here just generated 1 write, it gave it to the controller, and the controller dealt with all the extra stuff. All right? But today's CPUs are really fast, and they typically have cycles to spare, meaning that, they're not busy every single moment. And so, generating this amount of extra information inside of the kernel might not be such a burden, and typically, performance can be excellent in such a system. Okay. Also, because the logic's in the kernel, these disks out here can be IDE disks or SCSI disks, whereas typically these RAID controllers are only SCSI on a SCSI system, and so we can get away with a less expensive RAID system. We can actually, I'm going to show you how to set up here in a second, we can actually have a RAID system on a single disk. So just say instead of having 2 disks on our system, we've got 1 disk. But there's some information on this disk that is very critical to us. Okay, just say it's, the /var directory or something. Logging information is very critical to our system. And so we want to have a live mirror copy of that information. Okay, well, so what do? Well, we make 2 partitions on this disk, and we set up a RAID, software RAID system on these 2 partitions. So they're going to be mirror images of each other. So now, when the processor wants to write file F out to this partition, well, it writes file F out to this partition, and it also writes file F out to this partition. And so, this is a RAID system. This is RAID level 1. The 2 partitions are being mirror image. We only have 1 disk in our system, but we found this information, this data in var to be so critical that we want it to be mirrored, so we can set up software RAID to do that. Okay, and I'm going to show you how to do that now from the Linux installation screen. All right, so that's RAID for you. The differences between hardware RAID and software RAID, remember, is that this controller has all the brains in it, and for the software RAID, all the logic is actually in the kernel. The thing here is that you don't really see that these 2 partitions are associated with this device. If you were doing a graphical installation instead of a text installation, over here, the screen is basically the same information, but it would say mount point or RAID device associated with it, something like that. And over here, this would say, for these 2 partitions, SDA2 and SDA3, it would say something like /dev/MD0. And then up here for RAID device 0, it would say dev MD0. So you would see that partitions 2 and 3 would be associated with this RAID device 0. All right. Normally, I advocate text-based installations just for some of the problems that come up with graphical installations and graphics cards and things like that. But this is one case, and we're going to see another case in a few minutes, of where a graphical installation is actually a little bit nicer because it gives you a little bit more information. So instead of showing you the graphical one, I showed you the text-based one in case you did the text-based one and you got confused or something. I figured I'd show you the confusing one and just clear it up for you. If you're doing the graphical one, there's just a little bit more information, and it should be more clear how things are laid out. Okay, so there's our software RAID device, and it's for partition 2 and 3. There's still free space left over on our hard drive, so we can do whatever we want with that. We can create another RAID device. We could make swap space and other partitions that are not part of a RAID device, just like /boot was not part of a RAID device. So we can lay it out however we want. Again, just remember that this partition here is really taking up twice as much space, so if you're going to make RAID devices on your system and do mirroring, you're probably going to need slightly bigger disks than you're used to for whatever you're using it for. Okay, so that's a software RAID device. And now let's move on and talk about logical volumes. All right, let's talk about logical volume management, or LVM for short. LVM allows you to manage partitions. So if you set things up correctly when you're installing Linux, you can make it so that if a partition fills up, you can expand that partition in a nice, neat way. You're not going to end up wasting disk space or having to add new disks or anything like that. Okay, this is new to Red Hat 8.0. Other variants of Linux have had this around for a while. Red Hat didn't adopt it until version 8.0. So let's talk about some terms and concepts for LVM. Okay, the first term is the physical volume, or PV. Okay, the physical volume is associated with actual hard disk space. Okay, a physical volume cannot span more than one hard disk. So if you've got multiple hard disks in your system, you're going to have multiple physical volumes. All right, this picture I have here is a 2 GB disk in my system and a 4 GB disk. All right, and these are the physical volumes. Actually, this whole 4 GB disk is not part of my physical volumes because part of that disk is my /boot partition. So this is like a classic partition that we've done, just like in the RAID stuff. We didn't want /boot to be part of a RAID device. We also don't want /boot to be part of a physical volume. So /boot is going to be its own partition over here, let's just say 100 megabytes big, and then the rest of that stuff is my physical volumes. Those physical volumes then make up a logical volume group, which I've denoted here. Okay, so here this is 6 GB big, because these disks were 6 GB big, minus 100 megabytes that's used for the /boot partition. So this logical volume group is 6 GB minus 100 megabytes big. All right? Now that logical volume group, we take and we break that up into logical volumes. All right? And those logical volumes that are out here are a lot like partitions, but they're a little bit different. So they have a mount point associated with them, like /home, a size, 1 GB, and also a file system type, like ext3. Okay, so this is a lot like a partition. We're going to have a mount point associated with this logical volume that's 3 GB big with the mount point of the / directory, the top level directory. We're going to have a swap logical volume that's 500 megabytes big. And then we're going to have a logical volume here at the end that's free space. Okay, that's going to be about 1.5 gigabytes. All right, and now what you can do is, this is your system setup that you did at installation. If one of these volumes fills up, or say you want to increase, I've made it 100 megabytes big, fixed size, and so on. Okay, now you can see SDA1 is /boot, and it's 102 megabytes, and so on. All right, and this picture up here is like the picture of the disk. That should say SDA1 and 100 megabytes big, but it's so small it doesn't even fit in that little graphical window. Okay, so now I've done that. Now what I'm going to do is I'm going to create some partitions, and then we'll turn those into logical volumes. Okay, so here I'm adding a new partition, but now when I add the partition, I'm going to pick from this file system type list, I'm going to pick physical volume. Okay, remember that's the highest level in that picture that I just showed you on the whiteboard. Physical volume is what we're picking here. All right, I'm going to say, since I only have one disk on my system, I'm just going to say fill to maximum allowable size. I just want to fill up the rest of the disk with this physical volume, and then I'll break that physical volume into these logical volumes that will have mount points associated with them. Okay, so I'm going to say OK here. And now I've got this type is a logical volume manager, a physical volume in the LVM program. How big is it? It's the rest of the disk. It's the whole rest of the disk, from 14 to 522 cylinders, like about almost 4 gigabytes big. Okay, minus the 100 megabytes that I used for the boot mount point. Okay, so I'm going to say OK, and now I'm going to click on LVM. All right, so when I click on LVM, then I get this Make LVM Volume Group. All right, so the volume group name, remember in that last picture on the whiteboard, the physical volumes went to a logical volume group. Well, since I only have one physical volume, so that's the only logical volume group I'm going to have is containing that. Then the interesting part is when we break this up into logical volumes. Okay, the physical extent here, don't mess with this kind of stuff because there'll be a list here if we have multiple physical volumes to use. I only have one. They always make it in increments of 4 megabytes. Don't mess with that. Okay, and then what I'm going to do down here is I'm going to click on Add. All right, and I'm going to say Make a logical volume. All right, so I'm going to associate a mount point, a file system type, the logical volume name, which I don't change. You can give these actual names if you want. I just would rather leave it the way that they do it, and a size associated with that mount point. Okay, I'm going to click on OK. And now I've got, under my logical volumes names here, I've got logical volume 00 / home, and the size is 752. Now I'm going to add another one. Okay, and up here I'm going to say, oh, let's make some swap space 500 megabytes big. Okay, and you can see the mount point is not applicable, which it shouldn't be for swap space. I'm going to say OK. All right, and now I do another add, and I'm going to have the mount point / be size, say, 1500 megabytes or 1.5 gigabytes. All right, then I'm going to say OK, and that's it. All right, now what did I do here? Is the free space I have left over is 1232 megabytes. You can see that in this diagram up here. Okay, that's okay. It's okay to have free space, because when one of these things fills up, or if I want to just increase swap space for performance reasons, I can do that out of the free space pool. Okay, so now I'm just going to click OK, and now we get our picture here. Here is volume 00. The logical volumes associated with that are here, 0001 and 02. It's for / home, and swap space tells you how big each of those is. And then down here under hard drives, it's telling you exactly what's going on. SDA has been broken up into two partitions, SDA1, which is /boot, and SDA2, which is this volume 00. Volume 00 is described up here, what it's made out of. Okay, this partition, SDA2, is 3,993 megabytes big, even though the sum of these volumes here doesn't quite add up to that. You'll also see that volume 00 is only 3,984 megabytes big, even though the partition's 3,993. Well, those extra 9 that we're missing here, that is some overhead associated with the logical volume manager. Well, that's it. That's all there is to creating logical volumes from the installation program. Now we'll move out to the Linux screen to see how we deal with managing these once Linux is already installed, and we want to allocate space from that free pile over to one of these other partitions that we already created, or logical volumes we already created. I have to smack myself on the knuckles for that. All right, well, what I want to do now is show you some of the commands that you can use to manage logical volumes. All right, we use Disk Druid in the installation program to create our logical volumes, but if you're going to do any management to those after installation time, you're not going to be able to use Disk Druid because that's only an installation program, so you're going to have to learn some of these commands. So the first thing I want to do is just look at the info page for LVM. So LVM, it just describes what LVM is, and if you page down here, you can see some of the abbreviations that are used. It's good to understand these abbreviations because a lot of the commands use these abbreviations inside of the commands. Okay, so if we page down further, you'll see some examples here on how to create a physical volume and a volume group, and then how to create a logical volume group once you do that. And then we page down further, and you can see a whole slew of commands here to manipulate logical volumes. Okay, so if you do things like, add a new disk to your system and you want to make that physical volume part of your logical volume group, well, this is where you're going to turn to look up how to do this stuff, or these commands, and you can pretty much tell what each command does, right? Like lv create creates a logical volume, lv displays a logical volume, lv extend extends a logical volume, and we're going to do a command like this in a second when we go back out to the command line. Okay, and PV commands are for physical volumes, and VG commands are for volume groups. Okay, so if you need more information about LVM, because this introduction that I'm giving you is definitely somewhat superficial, it's just like the beginning of the iceberg, go to Sistina.com and you'll see a how-to page there. Like www.sistina.com has archived news groups talking about LVM. They have information for the /home directory. So now if I do that, you'll see it's extending logical volume 00 to 852 megabytes. Okay, and so there it says successfully extended. So now our /home directory has 100 extra megabytes in which to grow. Okay, and that was exactly the point of using logical volumes. It takes a little bit of overhead to manage that. You lose a little bit of disk space for that, but you get flexibility later on in how you extend these logical volumes, so because you might not be able to predict how your system's going to grow. Okay, so this is a good tool to get over some of those uncertainties about how your system's going to grow. All right, well, it's time to wrap up our nugget on advanced installation issues. We started by talking about RAID. We talked about the RAID levels, RAID level 0, 1, and 5, and how they were different. And we also compared and contrasted hardware RAID and software RAID. And we also set up software RAID on our single disk system so that a partition was mirrored on the disk for ultimate reliability. And then we talked about logical volume management. I gave you a brief synopsis of what it was. We set up LVM at installation time. I showed you a little bit about how you can manipulate LVM post-installation. And remember, there's extra info at www.sistina.com. All right, well, that wraps up this nugget on advanced installation issues. I hope you found this informative, and thanks for watching.